Okay, I'm going to do the second one on the back of the lens and mirror review. This one is here. I have a convex lens, which is converging, and notice the special case, it's inside of the focal point, so that means that it's going to give me a virtual image. Let's go ahead and do the drawing first, and then we'll work out the math. Okay, so the first one goes right through the center, and I'm going to use the star right here at the top of the tree, at the top of my object. There we go. Then the pink one goes parallel, and I'm making sure that I start at the same spot at the top of my tree, and I'm using my clear ruler to help make sure that I'm completely parallel. So I'm looking at the numbers here, how close the bottom of the numbers are to that axis. Straight over, it fracts, so it bends in through the focal point over here. Like that. And then the blue one, the focal point on the same side, right through the top. And when it hits the lens, it bends and fracts parallel on the other side. I'm using my clear ruler to help me make sure that it's as parallel as it can be. Alright, so these rays will never intersect over here on the real side, so I'm going to need to dot them backwards, and this is what's going to give me my virtual image. Again, making sure that it's nice and perfect. And the pink one. Alright, and it looks like they all cross right about there. Okay, now I need to go ahead and draw my actual image. I'm going to draw the tree trunk right down the center. Okay, making sure everything is nice and parallel. And you've got to actually replicate your image. Don't just leave it as a dot. Alright, so because it's on the quote-unquote wrong side of the lens, this is virtual. And it's also upright, and upright and virtual always go together, and as you can see, it's bigger. So let's do the math to work this out. Measure my focal point here, and it is 2.75. It might be better to measure the focal point before you start drawing the lines over it. Okay, I've got the distance to my object is 1.35. And the height of my object is 0.8. All right, let's go ahead and measure the height and distance to the image, and then we'll do the math and compare. It looks like 2.6. So the distance to my image is 2.6, but it's in the wrong direction, so it's negative, because anything back this way is going to be negative. And height Looks like 1.6. Right, so let's check our math and hopefully we will come up with answers that are close to this. My equation, 1 over f is 1 over di plus 1 over do. So 1 over 2.75 equals 1 over di plus 1 over do, which is 1.35. And my calculator, I've got 1 over 2.75 minus 1 over 1.35. Don't forget to take the inverse of that. And negative 2.65 is my di. And that's good because I got negative 2.6 here. I'm going to use my other equation, hi over ho equals negative di over do. That negative is part of the equation, so it just needs to stay there. I've got hi over ho, which is 0.8, negative 2.65, so those will cancel, divided by 1.35. So I'm going to cross multiply. I get a height of 1.57 centimeters. This all looks good. Here's the height by my math. Here's the height that I got from my diagram. And the distance from my math. And the distance on my diagram. So everything looks really good and close. I can tell because the di is negative that it's going to be virtual. And because the hi is positive, it's going to be upright. And upright and virtual will always go together anyway. And because it's bigger, it's bigger because the height is bigger than it used to be. And I can also solve for magnification. So magnification, hi over ho. So hi 1.57 divided by ho 0.8. My magnification is 1.96. And that means that it is bigger. So my magnification is greater than the number 1, so it's bigger.